Now, a long time ago, we talked about sinuses in the equine. This specimen here is showing the maxillary sinus right here. The bone has been cut away to show that. And we've got our frontal sinus up here. So there is our frontal sinus open from the outside. You'll see that on another video on a specimen that's got all the muscles and connective tissue intact. And if you look down in there, you can see down into the maxillary sinuses farther down. There's my finger coming through right there. So maxillary sinus is down in that area. Frontal sinus is this top spot. Oop, right up there. Maxillary sinus down here. You recall I mentioned it's got a rostral and caudal compartment to it. The caudal compartment is here. There's a divider right here, and the rostral compartment is over that portion right there. So rostral and caudal compartments of the maxillary sinus. This equine skull has been painted so you can see the different bones a little easier. The frontal bone is painted in blue right here. You can actually see our supraorbital foramen there. Frontal bone in blue. Parietal bone is back here in green. Temporal bone in yellow. And our occipital bone is in this pink color here. So the frontal sinus is up underneath this frontal bone in this location here. And you will see that on another specimen with all the soft tissue included. So frontal sinus up underneath that bone there. Now if you compare that to the cow skull, here's our cow skull here. You can see this frontal bone, it starts down here in the calf, but as you know, calves have that little rounded head like a little dog does, but then they get this big blocky head as they grow older. It's Dusty from the lab over here. This frontal bone will start growing in a caudal direction like this, and I see frontal bone. Our nasal bones are missing here. Frontal bone exists from the nasal bone up to the top of that high point of the head, but in the horse over here, here comes my blue, and I see the parietal in green and occipital in pink. Well, where did our parietal and occipital bone go? They were actually pushed over the back of this, and so if you look from behind, there's our parietal bone in green, and there's the occipital bone in pink. So here's a video of those skulls from behind. Parietal bone and occipital bone pushed completely over the back side of that skull. They're still sitting on top here on the horse. Now when the frontal bone starts to elongate and takes the position over the entire dorsal aspect of this skull in the cow, what happens is that frontal sinus that was right up here, like we saw in the dog and the horse, will grow out with that, and it looks like this. So here's the frontal sinus under that frontal bone of a cow. We've got the top of that bone chipped off, and you can see inside there. The brain is housed underneath this shelf of bone right here. The brain is sitting under that. There's a hole in it right there. So there's a big trabecular meshwork in here that supports that, so it's not just one big open cavern that can be caved in if you hit the cow up on top of the head. And coming off of that frontal sinus, there's a corneal diverticulum right here that goes out into that corneal process. So the corneal process is that piece of bone right here that's going to support that horn. So that's the corneal process of the frontal bone, and the corneal diverticulum is a diverticulum off of this frontal sinus into that corneal process. Now some clinicians may call this a corneal sinus. That's okay. That's what they're talking about there. But corneal diverticulum is the proper term, and it will go down into that process at that point. So frontal sinus on this cow, here's the orbit here from that point all the way back to the back of that head. Now as that corneal process grows, and you can see it's much longer in this specimen than it was in the other. That corneal diverticulum will grow out with it. We look at this horn over here, you can see that diverticulum growing on down into there. And if we come around and take a look at the end of that horn, that diverticulum is all the way out here at the end of it. It won't reach the tip of it. There's a piece missing here off that diverticulum that's gone, but you can, I'm sorry, off the process that's gone. That's why the diverticulum is showing here. So there's a hollow throughout that entire corneal process there. And if we look down into here, that's our frontal sinus down in there, looking through the corneal diverticulum at that frontal sinus. Now, we're not going to get down into all the foramina through which the cranial nerves exited in the cow and the horse. You really need to get your hands on those to see them. But what I do want to show you here, because you will hear this one mentioned in your large animal courses. This is a cow skull here. It's a polled animal, meaning it has no horns, so there's no corneal process there. But if we look to the orbit, here's our bony orbit right here. Down at the foramina behind it, I see two openings, one there and one here. The dog and the horse have three openings here. It was the optic canal, and that's the same in the cow. Then there was an orbital fissure and a rostral alar foramen. And if you remember, in that alar canal of the dog, there was a round foramen in there. Well, the cow does not have that alar canal, which means the round foramen would be open to the surface, and there would be no rostral or caudal alar foramina. So there should be a optic canal, orbital fissure, and round foramen. Well, what happens in the cow is that orbital fissure and the round foramen fuse into one structure. So both those openings coalesce into one. And this opening here, just caudal to this optic canal, this large opening here is called the foramen orbito-rotundum. Orbito for orbital fissure, rotundum for round foramen. So foramen orbito-rotundum. And one of the procedures that you will do to remove an eyeball from a cow is to do a nerve block where you're passing a curved needle back behind the eyeball to this point here to block the nerves coming out. And what you're blocking are the sensory nerves coming out from the trigeminal nerve. And that's where that would be blocked at that location there. So you will hear foramen orbito-rotundum at some point in time, I would imagine. And there it is with an old practical exam arrow sitting on it saying identify that opening. So foramen orbito-rotundum in the cow. Okay, here is a cow head that has some rather substantial horns on it. If you look just rostral to that horn here right in the temple, you see a corneal artery right here approaching that from the rostral aspect. Here's the corneal nerve down here coming in from the rostral aspect. Some people will drop blocks in here to block this nerve before dehorning a cow, but whether the nerve is blocked or not, anytime you dehorn a cow, you're going to get a major bleeder out of that corneal artery right there. So there's your corneal artery, corneal nerve in a cow.